Have you ever tried to disassemble an app only to be met with a wall of confusing code? It's frustrating, right? If you've ever faced this issue, you're in the right place. Today, we're diving into the challenges of disassembling iOS banking apps and how to tackle them. I totally get it. You might be wondering why some apps disassemble perfectly while others leave you scratching your head. You're not alone in this struggle. Many users face similar issues when dealing with banking apps. Let's look at a specific case. One user recently asked why they couldn't disassemble a banking app using Hopper Disassembler. They mentioned that while most apps work fine, this particular one just gives them useless output. Sound familiar? Let's explore this together. So what could be going on here? It's possible that the binary of the banking app is encrypted or obfuscated. This is a common practice among banking apps to protect sensitive information. We'll break down what that means and how it affects disassembly. And stick around. At the end of this video, I'll share some tips on how to potentially decrypt or analyze these tricky binaries. To begin addressing the user's issue with disassembling the banking app, we first need to confirm if the binary is indeed encrypted. The user can check this by using a tool called OTool to inspect the binary. If the binary is encrypted, the user will need to decrypt it. This often involves using a tool like dump decrypted or clutch to extract the decrypted binary from the app. Once the user has a decrypted binary, they can attempt to disassemble it again using Hopper. This should yield more meaningful results compared to the encrypted version. Additionally, the user should be aware that banking apps often employ advanced obfuscation techniques. This can include code obfuscation, string encryption, and anti-debugging measures. Finally, if the user continues to face challenges, they might consider using alternative tools like Ghidra or Radar 2 for disassembly, as these can sometimes handle obfuscated binaries better. Fun fact, did you know that many banking apps use advanced techniques like code obfuscation and encryption to protect their data? It's like putting your money in a vault that even the best locksmiths can't crack. Now let's look at the answers provided by other users. One alternative solution is to remove the iOS app encryption known as Fair Play. Since you have a jailbroken device, you can use a tool called Clutch to help with this process. To check if the app is encrypted, you can use the command otool-l binary grep a4 lc encryption info. Also, remember that disassembling apps may be illegal in some countries. That's all for that response. Let's see what someone else had to say. One user shared an interesting insight from the RSA show in San Francisco back in 2017. They encountered a company that specializes in obfuscating iOS and Android code. This company demonstrated a method where a web page could jailbreak a device without the user's knowledge, allowing it to patch an app to send banking credentials to a third party, all while appearing to function normally. This highlights a significant security vulnerability, especially for sensitive applications like banking apps. The user mentioned that there are tools available, such as Arcsin and Preemptive, designed to mitigate these risks. Here's a pro tip. Always keep your tools updated and explore community forums for the latest techniques in reverse engineering. This can save you a lot of time and frustration. And there you have it. With these tips, you should be better equipped to tackle disassembling those tricky banking apps. If you found this video helpful, don't forget to subscribe for more insights and tips on reverse engineering.